Ladies and gentlemen, please welcome Manager of Design Software, Andy Stump.
Good morning. I'd like to welcome all of you to RSTechED 2014. Is everybody excited to start the week? Good, good. My name is Andy Stump, and I manage the design software portfolio for Rockwell Automation. And just like you, I'm excited to be here today. Because if you think about it, our jobs are pretty amazing. Behind everything we do, food we eat, or product we use, there was a great idea that led to innovation, design, and manufacturing. And we all have a unique perspective on how these things were made. It's often a long and many times complex history of what it took to get that product to market. I'm sure each of you have your favorite how it's made story that you use around the holiday dinner table to explain to your family what you do. This story is our lives. It's what we do. It's what we enjoy, well, most of the time, and it's what brings us together this week. Each of you are here today looking for new ways to innovate, searching for tools to improve your business, and finding new ways to improve your automation productivity. And a key way to improve that productivity is through better collaboration. Since the beginning of time, humans have learned that you can achieve more through collaboration. Breaking a complex task down into smaller parts simplifies the overall problem. It distributes the work amongst several people and enables specialized focus. Outside of work, I help coach my 8-year-old son's soccer team. And we have this little boy we call the philosopher. He says the best things, but at the most random times. So one night, after he and another boy scored a goal, he runs off the field while everyone else is still playing and says, "Coach, together everyone achieves more." What a true statement. This is the true meaning of teamwork and collaboration. Automation design is no exception. Automation design is a complex task where many people and disciplines work together to achieve more. This includes all of you, the plant and corporate engineers, the system integrators, machine builders, and partners. All of you must work together to make the world we live in a better place. But let's face it, real-world collaboration isn't always easy, and it never stays the same. Systems continue to get more complex, and technology and tools keep evolving. This means that more people must work together, and more data must be shared every single day. So let's take a look at real-life collaboration. See how it is changing. Identify where opportunities exist to impact automation productivity. And remember, it's a journey. It's a collaborative design journey. So as we start this journey, it's important that we take a quick trip back in time. We can learn quite a bit by understanding how designing an automation system has evolved over the years. With each new innovation came a new set of collaboration workflows and challenges. In the early days of manufacturing, mechanical engineers would build a machine, while the electrical engineers would wire power to the system. These two groups would work together as they designed and built the system. But the roles were relatively isolated and focused. Granted, they each had their own collaboration challenges, but for the most part, the mechanical design team determined how that system would work. As system flexibility and performance requirements grew, so too did the innovative design of the system. Engineers began using contactors and relays to make control decisions rather than relying on pure mechanical means. And this changed things, didn't it? It did. This solution gave system designers more flexibility, and with that, new things were possible. But this introduced a new challenge. The mechanical designer no longer had full control over how the system worked. It became a shared responsibility. Where it worked best, the mechanical and electrical engineers were now thrust into a tight collaborative partnership for success. These different disciplines now had to work together to achieve more. And since innovation and technology never stand still, the relay-based system evolved into a computerized solution. These early PLC and DCS offerings gave users more flexibility than ever before. Let's see a show of hands. Who worked on early PLC and DCS systems? A few of you out there? Excellent. They were pretty innovative, right? They really changed the industry. So the industry had to adapt. It now needed to support collaboration between mechanical, electrical, and this new type of role called programmer. And these people use software. Wow, what a change. New tools, new methods, and new forms of collaboration with this new type of worker. And for the next several decades, this process continually got refined as tools improved. More recently, the technology curve of the new millennium ushered in a new wave of computer and software technology, along with its challenges, and you all know the rest of the story. So over the past several years, there's been an amazing evolution of automation systems leading to productivity improvements. What we learned from all of this is that with each innovation, new collaboration methodologies get established. New types of workers come into existence, and new challenges present themselves. It's an ever-changing landscape with many opportunities for continuous improvement. We just need to embrace it if we're to achieve more. And that is what Rockwell Automation has done. We've spent a lot of time looking closely at how users like you collaboratively design and build an automation system in today's world. We also strive to understand how new technologies will shape the future of collaboration. This represents a high-level overview of that workflow, where manufacturers, system integrators, and machine builders collaborate. In the beginning, a manufacturer establishes a project, writes a specification, and then determines who will help build the system. Depending on the scope of the project, this can be any combination of people. All of you must work together. It's how we build the great things we do. Now let's take a closer look at a couple dimensions of modern collaboration. We'll start with collaboration between the different disciplines of automation design and how they exchange data with each other. Several types of tools are used to design and build an automation system. These include electrical drawings, mechanical drawings, and piping and instrument diagrams, to name a few. Not that long ago, these were all paper-based, and over time have evolved into CAD drawings. But because they were just drawings, a number of people had to manually collaborate to pull important data from the sheets and key it into the automation system. As all of you know, this can be significant work and relatively error-prone. So over the past several years, most CAD vendors have evolved. Drawings are now based on data models, and system information is available electronically. This introduced a completely new opportunity for collaborative data exchange. But how do you easily exchange this data? I'm guessing many of you still manually enter data from drawings into your automation system, right? Few? Or you've built special conversion tools to start engineering from data exports. There's no shortage of innovation here. But is this the most effective workflow? We don't think so, because we all know the challenges. This is never a one-time data exchange. Things never stay the same. So how many of you face the challenge of keeping electrical prints up to date with the control system? We know that as the life of the system progresses, changes do occur. That's reality. So it's important that changes in the automation system are reflected in other systems and vice versa. Rockwell Automation and its partners recognize this need and have a solution. For example, a native data exchange between E-Plan electrical drawings and Rockwell Automation design software make this a reality. Designers can exchange electrical CAD data, such as I/O names and assignments, with the automation system, providing an error-free jumpstart on building your project. It's just that easy. This is real collaboration that leads to true productivity. Next, let's talk about building a machine. Designers use 2D and 3D drawings to represent their machine and validate their design. These modern-day tools apply physics models to represent movement, load, and inertia. This provides a designer a clear representation of behavior of the machine. For example, Rockwell Automation, in conjunction with our partner Dassault Systems, offer a data exchange between SolidWorks and Rockwell Automation design software. With this data exchange, automation engineers can optimally validate their machine design well ahead of building the physical machine. These examples were made possible by advances in software that resulted in a reliable data exchange at the core of the solution. These changes opened a whole new world of opportunity. So what else? What else can we expect to see in this area? Rockwell Automation recognizes that each of you have your tools of choice, so we embrace that. We are working on a standard system-wide data exchange interface that opens up a world of opportunity of productivity, regardless of which engineering tools you use. In the process industry, design of a new plant involves many people, including process and electrical designers, skid vendors, EPC firms, and system integrators. We envision a more collaborative automation environment supporting native data exchange between P&ID drawings and instrument lists with the automation system. For example, in a project following ISA 88 standards, the sheets many times offer organization and structure around units, equipment, and control modules. The devices and loops on the sheets can be used to create base controller code with linked HMI icons and faceplates, with alarm definitions, and with information dashboards. During operations, you can use these same mechanisms to reuse what was learned from one facility and apply that to your other production facilities for continuous improvement of the bottom line. The opportunities are endless with a standard, all-inclusive data exchange interface between tools. Now that is productivity. Now, let's explore collaboration within automation design tools themselves. This is where a team of engineers collaborate to write controller code, build HMI graphics, and create information dashboards for a project. Whether you are simply writing code or using a more complex library management workflow, automation productivity in this stage of development can have significant impacts to your business. But effective collaboration can be very challenging. That's why an understanding of how you work is so important. Let's start with multiple people simply writing code. Modularity and object-oriented programming techniques are key to a good design, whether in programming languages like C or Java, or automation languages like ladder or function block. With this in mind, Rockwell Automation continues to introduce new capabilities to support this approach. Once a good modular design is established, people need to start writing code. And this is where the challenge of collaboration sets in. How will you break the work down? How many people are needed? And will they all be in the same location or distributed globally? How will they share what they work on? Will they work separately and then bring that work back together? How many of you ask yourselves these questions every single day? Some of you? All of you? How do you solve it? Do you set up agreements on who's working on what? Or do you give specific parts to certain people? When we take a step back, we may find it interesting that these challenges have long been solved in traditional software development. But why not comprehensively in automation? Rockwell Automation thinks this is a very important question to ask because it helps us understand where we are and how to best evolve products for the future. In most cases, automation engineers and plant support staff are not programmers by degree, and because of that, the automation software environment they use has evolved differently over time. In traditional software design packages, comprehensive version management systems are in place, and sophisticated code branching and merge tools support multi-user workflows. But these add a level of complexity and overhead for programmers. So what we see is that the automation industry hasn't fully embraced these methods. But should it? We believe so, but in a way that each of you are comfortable with. It needs to be in a way that adds value. It can't disrupt your common workflows and lets you adopt it when it makes sense for your business. So what's available today and where are we going? First, let's look at version management. Rockwell Automation provides tight integration between Studio 5000 Logix Designer and FactoryTalk Asset Center. Directly from Logix Designer, users can access code from the managed repository. You can simply check it out, do your work, and then check it back in as a new version. All of your changes are tracked and managed. Work confidently knowing that the system is backing you up. Next, let's talk about people working together on the same thing. In discussions with many of you, we have heard loud and clear that tools need to evolve in this area to better support the workflow. So in the coming release of Studio 5000, new capabilities have been added to not only compare code, but to then merge changes back together. This significantly helps multiple people collaboratively writing code on a project to be more productive. Simply open two projects, do a quick compare, and then merge that work together into a consolidated project file. Since this also works on previous versions of Logix, I have a feeling many of you will be able to take advantage of this right away. But how about situations where multiple people need to work on an online running system? A notable capability of Logix is the ability to have multiple people online with a running controller. Changes can be made and synchronized instantly while people work online. And with the introduction of Studio 5000, comments and descriptions do the same thing. Likewise, in FactoryTalk View, designers can add or update graphics to the running system. Simply make the change, and the next time the operator calls up the screen, it will be updated. Simple, collaborative, and productive. That's the focus for Rockwell Automation. And while we're on the topic of building a project, it only makes sense to discuss code reuse and library management. What a hot topic these days. Everyone wants to maximize the reuse of their unique content. It just makes sense. Why do the same thing over each time? It just costs more, it takes longer, and adds extra risk to a project. So let's spend a few minutes here. I think we're going to find some amazing productivity savings and better tools, content, and collaboration. Reuse can come in many forms. Simple reuse from project to project, or more formal approaches where official libraries of code get managed and reused. In both cases, it is common for one group to build library content, while a different group will pull from that library to build a project. This is collaboration at its finest. But how can multiple people efficiently do this? How can you collaboratively create, store, and manage content? How can you reuse it effectively? I'm sure each of you ponder these questions on a regular basis. These are some of the same questions Rockwell Automation considers as we look at the collaborative reuse workflow. What we find is that you use native automation tools like Logic's Designer and FactoryTalk View Studio to create your content. But then many of you rely on custom tools to manage and reuse it more effectively. For complex reuse strategies, this makes sense. But managing custom tools adds extra cost to doing business. Because of this, Rockwell Automation understands that there is tremendous value in supporting simple reuse workflows directly in the native products. So this was a focus in the coming release of Studio 5000. Rockwell Automation spent time understanding this reuse workflow and has introduced several new capabilities that let you better modularize code, organize it, and then reuse it across projects in a simple copy-paste, drag-drop, import-export workflow. Users simply create the content, store and version it in the native project file, and then reuse it as needed. With simple wizards and configurations, the system will do the rest for you. With these new capabilities, this workflow is significantly simplified and helps multiple people to more easily reuse content during project development. For many of you, it may even eliminate the tools that you currently manage for the same purpose. Let the automation system do it for you. And the system continues to evolve to support better real-world collaboration, but the evolution doesn't stop there. Rockwell Automation continues to drive collaborative reuse in a number of areas. The first is through pre-built content, and another is through using enhanced tools to configure that content. Both of these support a separation of functional expert from application expert. The goal is to enable the functional expert to build reusable content. This content will be built up and delivered by many of you over time, and it continues to come from Rockwell Automation. For example, the Plant PAX process library and accelerator toolkits offer pre-built content that is managed independently from any given project. It's made available for application experts to use. The benefit here is that the application experts don't need to know how it works at the core. They just need to understand how to configure and use it in an application. And having the automation system support multiple application experts reusing content through simple wizards and configuration dialogues will have a profound impact on your productivity. So we've talked quite a bit about modern collaborative design and where we see certain areas evolving over time. But what's next? What's the next big evolution in collaborative design? Rockwell Automation sees several opportunities here. One of today's biggest design challenges is turning your vision into an actual running machine or system. At some point, you need to build it, you have to control it, and then tune it to see if it works. If you don't get it right the first time, making changes can be very costly and time-consuming. So this forces us to ask the question, how do you get the system working without having to build it first? The answer is virtual design. Over the past couple of years, technology has significantly evolved. New software packages offer pretty amazing virtual machine and system modeling capabilities. This helps users, like yourselves, model full system behavior in a way that does not require the physical equipment. For machines, it could be inertia, load, and movement. For process, it's reaction, rates, and flows. These models, coupled with an emulated control system, gives you a way to completely design and test your system before it is ever built. This gives designers the freedom to experiment with different solutions and immediately see the impact of the modifications without costly rebuilds or wasted time waiting for mechanical parts to be made. This new approach leads to optimized machine design and system design, and it opens the door to greater innovation at a much greater pace and at a much lower cost. And who doesn't like that, right? So what are we doing to support this? In one example, Rockwell Automation, in conjunction with our partner Dassault Systems, is working on a prototype where a complete virtual machine model is connected to an emulated control system through an industry standard called Functional Mockup Interface, or FMI. In another example, Rockwell Automation is working with our partner MathWorks to connect sophisticated system models to an emulated control system for the same purpose. In both of these examples, data is exchanged between the two virtual environments, enabling engineers to prove out the design well ahead of building that system. These deliver on the belief that collaboration between virtual systems offer tremendous productivity savings. However, each new innovation brings a new set of challenges, and this is no exception. Virtual design requires a different expertise than before. Just like the introduction of the programmer role back in the early days of PLCs, a new role is evolving, the virtual designer. This virtual designer needs to understand the modeling software and be proficient in its use. Yes, developing this new type of expertise does require some investment, but the benefits have proven to pay off in a significant way for early adopters. The only question to ask yourselves is, can you afford not to? So this brings us back to where we started. We all know that consumers continue to demand more specialization, higher quality, and greater access to products every day. Just walk down your grocery store aisle, shop online for the latest tech gadget, or test drive the newest model of car. New and exciting things become available every single day. What you don't create, your competition will. So it's up to all of us to find new and better ways to innovate, to collaborate, and to be more productive. As we end today, I leave you with 3 action items. First, review your training list. You make a commitment every year to attend training. Make the most out of it. Sign up for sessions and training that can impact your business the most. Take the opportunity to learn as much as you can. Second, do an inventory of the tools and workflows that you use in your job. Map it out. Understanding what you do and how you do it will help you improve and make it better. Take what you learned this week home with you, collaborate better, and improve your productivity. And third, invest in your future by having an open and inquiring mind about new technologies and trends. Never be content with how it's always been done. Continually question how new things can improve what you do and how you do it. It's how we keep improving. Thank you for your time today. And remember, Rockwell Automation is here to lead you on a journey into the future. It's a collaborative design journey. Thank you.